Hello, my name is Kurapati Jayadurga Harshita, bearing roll number 90 of ECV section second year. Today, we in this topic, today my seminar topic, EDC seminar topic is fundamental process in electronics, which is nothing but rectification process, which takes from the transformer all the way to the voltage regulator. This journey is very essential for understanding how we convert AC to DC, which is nothing but an alternating current to usable direct current for electronic devices. So let's begin with the power conversion. Power first, the most of the electronic devices which we are using in a day-to-day life, that is mobile phones, laptops, etc., all need the DC current, whereas the supply which we are getting from the power station is AC. So here there is a need of conversion from AC current to DC in electronics. So this is not a single process, it involves many stages, which is transformer stage, rectifier, filter, regulator. The transformer, the main job of the transformer is to adjust the voltage level, and the next is the rectifier, which converts the AC to DC, and next is filter, which smoothens the output, and next is voltage regulator, stabilizes the voltage. So each step plays a very pivotal role or important role in power supplies, and here by ensuring this we'll get the safe and reliable output for most of the electronic devices. First, let us know about this is the block diagram of the rectification process. First, the input sinusoidal is given to the transformer. Here, the output which we are getting to the transformer is given as the input to the rectifier. The input the rectifier converts AC to DC, and this output is given to the filter as input. Here, which is converted in this filter, it smoothens the output and it generates the output, and it sends the voltage regulator. Here the voltage regulator stabilizes the voltage. These are the four key steps in the rectification process. The first diagram is transformer. What is a transformer? A transformer is a device which converts the electrical energy, which transfers electrical energy between two or more circuits through the electromagnetic induction. It can be either step up or step down. The name itself says that step up means increase the voltage, whereas step down means decreases the voltage. It works on the basic concept electromagnetic induction. It can be either step up or step down on the requirement of the user. So these are the different types of transformers which we are using in day-to-day lives, which is nothing but step up and step down, and center tap transformer. As we have discussed, step up is used for increasing the voltage, whereas step down is used for decreasing the voltage. Center tap transformers are used in full wave rectifiers for rectification process. This is the block diagram which is mentioned below. It is the block diagram of the center tap transformer, which we will be using in full wave rectifier. The output of the transformer is also AC, but here the voltage level is suitable to pass through the next stage, which is nothing but rectifier. Before knowing to know rectifier, we should know what is rectification. These are the output characteristics of the transformer. Here we have this, as we observe, the out the outer sinusoidal waveform is the input which we are giving to the transformer, whereas the inner sinusoidal waveform is the output which we are getting from the transformer. It is very suitable for the next stage of rectification, which is rectifier. So this is the transformer output characteristics. Second one is rectification. Rectification means converting the AC to DC. Here we use the diodes. In the diodes, it only allows only the current to flow in only one direction. There are different types of different types of rectifiers based on its own applications, based on its own advantages. The main output. This is not the final, but here the rectification means converting AC to DC. The first input is alternating current, whereas the required output is direct current. Here, this is the input which we are giving, and this is the output which we are getting. So next is full wave rectifier. The name itself, half wave rectifier. The name itself says half, which uses only one diode. It only works for the first half of the AC cycle, and it blocks the other half. While it's very simple, but it is not very efficient because because only half cycle of the AC is used, another half cycle is waste. Half cycle of the power is wasted, so it is not considerable. So to compensate it, we have introduced the full wave rectifier, center tapped rectifier. Here we use two diodes. It is a center tapped transformer. Here both half cycles of the AC are used and given. But whereas it is not efficient, it is not most efficient than the full wave half wave rectifier. The most efficient is the full bridge rectifier, which we will discuss next. Here in this full wave rectifier center tapped, we use only two diodes here. First diode is here and second diode is here. This is a transformer. And next is full wave bridge rectifier. It uses four diodes. No center tap is required. But here it gives a more efficient DC output. As we have observed here, there are four diodes. This is the input signal which we giving to the which is passed to the transformer. And this is the output which we will getting from the full wave rectifier, which allows the positive first half of the half cycle, and the negative half of the half cycle is also passed on only positive side. Because of this, power is not wasted as full wave half wave rectifier. The comparison between the rectifier types. First is the full half wave rectifier. It uses only single diode, but it is very simple. But here it is very inefficient because of only half of the cycle is used and the half of the power is wasted. And next one is the center tap transform rectifier, which has only two diodes. Here in this rectifier, it is efficient more compared to half wave rectifier, but whereas the bridge rectifier is more efficient than these two. It uses the four diodes to rectify. It uses four diodes to convert AC to DC. It is more efficient and it is widely used in many applications. And next one is filter. The main purpose of the filter is to the after rectification we will get the output. In the half wave rectifier, the other half is neglected, whereas the first half is here. It removes the ripples and generates the. It is not a pure, but it is not pure DC, but it is has a pulsating DC. This is why we use filters. The job is to smoothen the surface, and here ripples are reduced. The first step is capacitor filter. It stores the charge and discharges discharge or releases during the gap. Here, this is the output which is the input which we will give into the uh, rectifier, which will give AC supply. And here, the half wave rectifier output. Here it is given in the dotted lines. Here the capacitor charges, and in this slope it discharges. Again at the peak point it charges. Up to peak point it charges and again discharges. In full wave rectifier, this is the same process. Up to full wave, up to peak value, it is charging, and here it discharge, and here full charge, and here discharge. This is the most of the ripples are eliminated in this filter. There are different types of filters: inductor filter, LC filter, CLC filter, trade-off in ripple reduction. In LC is nothing but inductor capacitor filter, which is also known as L section filter, and second filter is CLC filter, which is also known as capacitor inductor filter, capacitor inductor capacitor filter, which is also known as pi section filter. Here CLC is most efficient, but whereas we widely use the capacitor filter to reduce the ripples. Next is the voltage regulator. Why? What is need for voltage regulation? The output which we are getting from the filter is not the direct current. Here it keeps the voltage, output voltage constant. Because of it, as it keeps the voltage constant, it provides sensitive electronic devices which will be useful. There are different types of voltage regulators. First is linear voltage regulator. They are very simple and reliable. Examples are 7805, 7812. They maintain a fixed output voltage and they're very easy to use, but they are little very it is not very efficient for high power applications. For low power applications it is very suitable, but whereas in high power applications it is not very efficient. To overcome this, we have introduced another one is switching regulators, which is very high efficiency. Buck boost, which is nothing but buck, which is step down voltage, boost, which is step up voltage, and buck boost, which can do both step up and which can step down or steps up the voltage. Here it is very complex, but it performs very well compared to a linear voltage regulator. It is very used in battery power devices. And next, this is the whole summary. Transformer, as we have discussed, the transformer adjusts the voltage, and here the adjusted voltage is passed to the rectifier. In the rectifier, it converts the AC to DC. The transformer output is also an AC. This AC is transferred to the rectifier. It converts the AC to DC. Here in the DC, we will not get all the full the DC. So to smoothen the output, here we use the filter. Also after the filter, after some there will be some voltage difference. Here the final step is the voltage regulator stabilizes the voltage and gives the direct voltage which we'll be using in many day-to-day applications. Now let us explore the real world applications. In these real world applications we use mobile chargers, laptop chargers, and most of the power in industries, most of the which needs DC current, we have the applications or the devices which needs DC. Compulsory rectification is process you used in households. So conclusion, the rectification is not only the process, it involves it is a huge beautiful blend of physics and engineering. It transforms the raw AC current to the DC current, which is useful in digital electronics and power electronics. It is understanding this process is very important because it is fundamental for electronics engineer. Thank you for giving me this golden opportunity.